All right, here's the warm-up for 2.3, the first part, which is what we completed yesterday. We're going to start with dividing, and this is at raised to the what you're dividing into it, or the divisor's got a squared on it, which means we have to use long division. So I'm going to look at my dividend, make sure I've got decreasing degree order, nothing's missing, which is the case. So that goes under the division bar. What I'm dividing by also has to go in decreasing degree order and can't miss anything, and it's a 0x. So that goes on the outside. Now it's divide the first into the first. So this would be x squared, and I'm going to multiply it times all three terms. X squared times x squared is x to the fourth, plus a 0x to the third, minus 3x squared. Now I'm going to change my signs and add. This cancels. Negative 2x to the third minus 0x to the third is negative 2x to the third. Positive x squared and positive 3x squared is positive 4x squared. Bring down the next term. Outer, again, x squared to negative 2x to the third would be a negative 2x. Multiply it times each of the terms on the outside. And I get negative 2x to the third plus 0x squared plus 6x. Change your signs. These cancel. 4x squared minus 4x. Bring down that last one, which is minus 8. And first into first again is a positive 4. Multiply that times each of the terms on the outside. 4x squared plus 0x minus 12. Change your signs. Cancels. Negative 4x and a positive 4 is your remainder. So when I write this out, my quotient is x squared minus 2x plus 4. And it would be plus a negative 4x plus 4 over x squared minus 3. But remember, we don't allow that leading number to be negative. So I get x squared minus 2x plus 4 minus, but when I pull it off of, it's going to come off of both of those terms. So the 4x becomes positive, but the 4 becomes negative. You're dividing both of those by a negative 1 in order to take it out and put it in the front. All right, number 2 says use synthetic division and the remainder theorem to find the value of f of 2 for the function f of x equals x to the third plus x squared minus 11x plus 10. So the 2 stays as 2. It's not x minus 2, so it doesn't change signs. Well, it's not x plus 2, where it would change signs. That is my 2, is my x value. That goes on the outside. List my coefficients, making sure it goes from decreasing degree, not missing anything. So this is 1, 1, negative 11, and 10. Bring down the 1, multiply it by 2, put it in the next column, add it, multiply it by 2, put it in the next column, add it, multiply it by 2, put it in the next column, add it, and this tells you that f of 2 is just 0. So again, the remainder on that is your overall answer. Don't worry about this question. We haven't gotten to it yet. We will save this for after your test. Okay, so for the 1.6 to 2.3 test, this is obviously on campus. You will get to use your calculators, and you'll need them at some point. You'll need a graphing utility at some point, which when we get to, I'll tell you. We started with inverses. This was 1/6. So there's the tests to see if something is 1-to-1. Which means it has an inverse. The first is from points. And for this, the y cannot repeat with a different x. So remember, the test to see if it's a function is that the x can't repeat with a different y. For an inverse, it's the y can't repeat with a different x. From an equation, The x can't be raised to even power, or the x in absolute value. Both of these mean that they do not have an inverse. Unless, of course, it's restricted. So if you are going to take a function like f of x equals x squared, let's say plus 3, but I restrict it to x has to be greater than or equal to 0, that would be like a parabola that's shifted up 3 places, and normally it's like that, which would fail. But if I say it has to be greater than or equal to 0, that means only the right part of that graph is what I'm looking at, and that would pass your inverse test, which leads to the last test, which is from a graph. Okay, and this is the horizontal line test. So again, if it was just a regular parabola, it would fail, but if it was restricted like the one before it, it would pass. Then we had finding the actual inverse. So we take our function, we substitute y in for f of x. We switch the x and the y. We solve for the new y. And then the last step is make it back f negative 1 of x. So if I had an example, if it said y equals negative 2x plus 1, then I'm going to start, it would say f of x equals, and I would start by making that y. I would switch the positions of the x and the y, solve for the new y, and I would get y equals x minus 1 over negative 2, or f negative 1 of x equals x minus 1 over negative 2, which can also be written as negative x over 2 plus 1/2. So both of these would be fine. If it's multiple choice, obviously you'll see one or the other. Okay, then came quadratics. So we started with taking a function that was not in standard form and putting it into standard form. This is our complete the square. And this is what you did your video on. So to go from this is called quadratic form, okay? To go from quadratic form to standard form, we're going to follow the steps on the right. We're going to group together the first two terms, leaving a space for that third term, and bumping out the last term. If a is not equal to 0, which in this case it's not, it's negative 3, we're going to factor that out. So take out a negative 3, I get x squared minus 5/3 x, because you have to take it off of both of those terms. Leave the space, parentheses, plus 2. Then I'm going to do b over 2 squared. So I have to take negative 5/3. I don't have to worry about the sign because I'm always going to square it. 5/3 divided by 2, which is the same thing as multiplying by a half, and then I have to square it. I get 5/6, and 5/6 squared is 25 over 36. That's what I'm going to add inside the parentheses. And then normally I subtract it from outside the parentheses. But because we took something out, I have to multiply it by that first. That's going to go in 12 times. These both become positive, so this would be a positive 25/12. Now I'm going to rewrite it negative 3x squared minus 5 over 3x plus 25 over 36. And now I have to add these two together. So 2 becomes 24 over 12 plus 25 over 12, and I get positive 49/12. Now I need to factor what's inside the parentheses, so I square root the first term, square root the last term, take the sign from the middle, put it in the parentheses and square it. This will be the same thing that you got before you squared over here, plus 49/12. So there's my function in standard form. From here, my vertex is hk, so it's what follows the x, which would be 5/6, and then what's on the outside, 49/12. The axis of symmetry is x equals, and a lot of you got points off on that quiz because you forgot, not a lot, but people did, because we forgot the x equals, so I want to make sure I do x equals 5/6. The domain on parabolas is always all real numbers, or negative infinity to positive infinity, because my arrows point left and right. And the range, if my parabola opens upward, it's going to be the k value to positive infinity. If my parabola opens downward, it's going to be negative infinity to k. Both of those k's get a bracket. So because this original function has a -3, or even down here it has a -3, I know this points down, which means I'm going to go from negative infinity up to the k value, which is 49/12, and put a bracket on that. To find the x-intercepts, we want to plug, let's do the y-intercepts. Plug 0 in for x. So I'm going to get, and I do that easiest from the original form, -3 times 0 squared plus 5 times 0 plus 2. This is gone and this is gone, it's just 2. So that'd be 0, 2. The x-intercept, you have two choices. Use my standard form, making sure you use the even root property, or take your original and see if you can factor it. So this would be a -3x and an x. I want the larger one to be positive, so I'm going to do a +2 here. Test it out, +1. This is -6x plus 1x. So my signs are not right. This can also both be negative, and now I get a +6 minus a 1x, and that's the combination I'm looking for. So I set these each equal to 0, and I get -3x equals 1, x equals -1/3, and here x equals 2. Remember, intercepts are in coordinate point form. All right, last up on this one is your max and min. If your parabola points upward, then you're going to get a minimum value. If your parabola opens downward, it's a maximum value. Both of them are just the k's. So in this case, because it points down, I have a max value, and the max value is just my k, which is 49/12. So now if I went to graph this parabola, I would plot this is my vertex, 5/6 and 49/12 is the same thing as 4 and 1/12. 1, 2, 3, 4, and 1/12 right here. My x-intercept, my y-intercept, let's do that next, is 2. My x-intercepts are -1/3 and +2. And draw your parabola. Okay, what happens when you keep it quadratic? So that's your other option. You are going to get a question that asks you to complete the square, so make sure you know how to do that. But it may not ask you to find all the information after. You may get this option. So to find the vertex, the h is -b/2a, and then we plug that back in to get the k. So if I did that on this example, a is -3, b is +5. So -5 over 2 times -3 would be -5 over -6, or 5/6. And that's the x coordinate of my vertex. Plug that back in, -3, 5/6 squared plus 5 times 5/6 plus 2. -3, 25 over 36 plus 25 over 6 plus 2. 3 goes into 36 12 times, -25 over 12, multiply by 2 here, 50 over 12, put this over 1, multiply by 6 here, by 12 here, and it's 24 over 12. Add this together, and I get 25 plus 24, and I get 49/12, which is the same k we got from before. So you won't be asked to do this twice. Just realize that there are two different ways to do it. Okay, x-intercepts would be the same. I would plug 0, well, y-intercept, plug 0 in for y, and I get just that 2. And then the x-intercepts I would factor, and I would get the same answer as before. Also in 2-1 was the reverse. So what happens when you're given the vertex and a point and you want to find the equation? So remember standard form, and probably something you want to put on your reference sheet is y equals a x minus h squared plus k. The vertex is your h and your k. The point is your x and your y. Take and plug that in. So 12 equals, oh, not 12, sorry. 5 equals a. X is 12 minus the h is 3 squared plus the k, which is a negative 4. So 5 equals a, 9 squared minus 4. Add the 4 to both sides. 9 equals a, 9 squared. So a lot of you forgot to square this 9. 9, a, 81. Divide both sides by 81. A equals 1/9. Then I plug back in just the a, the h, and the k. So y would equal a, which is 1/9, x minus h, which is 3 squared, plus k, and that's a negative 4, so it becomes minus 4. Okay, also in this section was your calculator questions. So let's look at these. The first one says the height, y, and feet of a punted football is approximated by, and we did this one in the notes, okay? But what we did is we typed this into our graphing utility, so you definitely want to practice this out on a graphing calculator app or the graphing calculator itself. Remember that when you get that y equals, you need to have the negative, open parentheses, 16 divided by 2025, close the parentheses, x squared, plus open the parentheses, 9/5 x, plus open the parentheses, 3 divided by 2. So that's how you'll type it in. It said to use the graphing utility to graph the path of the football. And then it said how high is the football when it's punted. So remember, if this is my x and y axis, if it's punted, it means where it is on the y, which is going to be your y-intercept, which in this case was 3/2 or 1.5. What's the maximum height of the football? So for this, we want to find this point here, and we're going to trace our graphing calculator. Okay, so I graph these on my graphing utility, and then notice that C says, what's the maximum height of the football? So I double tap the screen and I find maximum. I tap at the top and I get this coordinate point here, 114.9 and 104. So the maximum height is just the y coordinate, which would have been 104 feet. Then it says, how far from the punter does the football strike the ground? So I want to know when it comes back to the ground, which is going to be the 0 that's over here. And that coordinate point is 228.6, so we're going to say approximately 229 feet. 66, this example from the book says, the path of the diver is approximated by negative 4/9 x squared plus 24/9 x plus 12, where y is the height in feet and x is the horizontal distance in feet from the end of the diving board. What's the maximum height of the diver? And then verify your answer using a graphing utility. So if I didn't have a graphing utility, which you will, I would want to find the height of this, and that's your k. So I can find b by doing negative, I can find h, sorry, by doing negative b over 2a, plug that back in, and I would get the k. But we have our graphing utilities, so we're going to use them. So on this one, I didn't have to zoom out quite so much like on the first one. Okay, my window here is kind of just like that negative 10 to 10. And I want to know the maximum height of the diver. So again, maximum height is going to be the k value here. My coordinate point there is 316, which tells you that the maximum height of the diver is 16 feet. If for some reason it had asked, like, like from the original diving board, how far over does that max happen, then I would want to know the x coordinate there, which was 3 feet. So just think of all the variations of the kinds of questions you can get, either an intercept question or a max-min question based on the graph that you're going to graph using your graphing utility. Okay, 2.2 is polynomials are of higher degree. This was still on the quiz. So we started with n behavior. Given that a x to the n is the term with the highest exponent in your function, a is the coefficient on that highest exponent, you have two options. If your n is odd and it's positive, then if your n is odd, but it's negative, coefficient on the front is negative. Then you have if n is even, but the term is positive, and if n is odd, and the term, oh my word, sorry, the end is even, but it is negative. So if it's odd and positive, then it falls left, rises right. If it's odd and negative, it rises left, falls right. If it's even and positive, both point up. And if it's even and negative, both point down. So you will get a question that simply asks you for your n behavior. Just make sure you know how to do it. Then came your zeros. So for your zeros, you're going to set your function equal to 0, and you're going to factor and solve. You're going to note, of course, your multiplicity, because which is the number of times a root occurs. If it's even number of times, it bounces off the axis at that point. If it's an odd number of times, it crosses through. So here's an example. This one has a negative 2x to the fourth plus x to the sixth minus 3x squared. First of all, it's not in decreasing degree order. It would be x to the sixth minus 2x to the fourth minus 3x squared. Now I can look at the one on the front, which is an even exponent, and it's positive, which means these are both pointing up. To find my zeros of multiplicity, I would want to set this equal to 0. I can take out an x squared, and I get x to the fourth minus 2x squared minus 3. Factor that out, and it's x squared minus 3, positive 1. I get x squared equals 0, which means I have a 0 with a multiplicity of 2. I get x squared equals 3, so x equals plus and minus the square root of 3. And I get x plus 1 equals 0, so x equals negative 1. So my zeros are 0 with a multiplicity of 2, 1 negative root 3, 1 positive root 3, and 1 negative 11. The y-intercept I get by plugging zeros in. I already know this answer because I got 0 as a 0. Now take it to your graph. So I've got 0, negative root 3, which is like 1.4, negative 1.4, positive root 3, which is like 1.4, 1.7 actually, and negative 1. These both point up. I know it bounces off the 0, so it's going to come down, it's going to come back up, it's going to bounce off the 0, it's going to come back up, and then it's going to hit my point at that root 3. So as long as you're plotting your zeros and your intercepts, you should have enough of a graph, okay? I don't need to figure out, I don't have to plug in something in between negative 1 and negative 1.7 to figure out how low that goes because it's so small. But you do need to have your zeros and your graph on that. All right, finding the polynomial function that has the given zeros. So what happens when I give you the zeros and ask you for the equation? That's what this kind of example is. So I'm going to put an x minus in front of each of these, which changes the signs. X minus a negative 2 becomes x plus 2. X minus 3 plus root 2. X minus 3 minus root 2. So x plus 2. X minus 3 minus root 2. X minus 3 plus root 2. Remember, anything with a root that's opposite is going to cancel out. So I'm going to start by multiplying out those two. So I'm going to bring down the x plus 2. I'm going to multiply this. X times x is x squared. X times 3, negative 3x. X times root 2, positive root 2x. Then I go to the negative 3. Negative 3 times x negative 3 times negative 3, negative 3 times root 2. Then I go to the next one, negative root 2x, positive 3 root 2, negative root 2 times root 2, which is 2. Bring down your x plus 2. I've got an x squared, negative 3x, and negative 3x, which is negative 6x. Positive root 2x and negative root 2x cancel out. Negative 3 root 2 and positive 3 root 2 cancel out. And all that's left is the 9 minus the 2, which would be a positive 7. Now I'm going to FOIL out what's left. X times x squared is x to the third. X times 6x, negative 6x squared. Positive 7 times x. 2x squared, negative 12x, positive 14, x to the third, minus 4x squared, minus 5x plus 14 equals 0, or f of x, because that's implied by saying these are solutions. Okay, last section was 2-3, which is how we start the day, and this is what we did yesterday. We start with long division. So remember, you want to look at all the terms. You want to make sure they're in decreasing degree order. Nothing's missing. On this one, there's not. So I'm going to write out my dividend. Do the same with what you're dividing by. Make sure it's highest exponent down to none and nothing's missing. That's the case. So I'm going to put that on the outside of the divisor. And then it's first into first. So what would I multiply x squared to get to 2x to the third? And it's 2x. Multiply it times all three terms on the outside. 2x to the third plus 4x squared minus 2x. Change my signs. Cancel. 3x squared plus 6x. Bring down the minus 3. Plus 3. Multiply it out. 3x squared plus 6x minus 3. Change your signs. Cancels, cancels, and cancels. So this is a remainder of 0. So my answer is just 2x plus 3. If I did have a remainder, remember that that remainder would get put over the divisor for my answer. Okay, the remainder theorem in synthetic division to find the value of the function. So if I give you f of x and I ask you to find a function value using the remainder theorem in synthetic, this just means take whatever inside the parentheses, put it on the outside of our synthetic division, draw the bar. Make sure every term is here in decreasing degree order. I've got x to the third, x to the second. I don't have an x, so I'm going to add in a 0 there. Write my coefficients, 3, 1, 0, negative 4. Bring down the first one, multiply it by what's on the outside and put it in the next column. Add it. Multiply it by what's on the outside, put it in the next column, and add it. Multiply it by what's on the outside, put it in the next column, and add it. And the remainder is the last number, which is the same as what I would get if I plugged in negative 2. Okay, then came this first one. We're going to ignore the Descartes rule because we didn't do that yet. Show that x is a solution of the third degree polynomial equation and use the result to factor the polynomial completely. List all the real solutions of the equation. So if I'm telling you that 2 is an x or a solution to this equation, then I can put 2 on the outside. Look at my coefficients, make sure that they go down in decreasing degree order and there's nothing missing. There's not. So it's 2, 3, negative 11, negative 6. Bring down the 2, multiply, put it in the next column, add it, multiply, put it in the next column, add it, multiply it, put it in the next column, add it. If this is not 0, you did something wrong because by stating it's a factor, my remainder should be 0. Now take what's left, 2x squared plus 7x plus 3, and factor it to find my remaining terms. 2x, x, this would be a positive 3 and a positive 1. That gives me 6x plus 1x, which is what I have in the middle, 7x. So my complete factorization is 2x plus 1 times x plus 3 times x minus what I was given initially, which is 2. That's complete factorization. The list of all the real solutions would be negative 1/2, negative 3, and positive 2. All right, so the rest of this Descartes' rule, don't worry about it. It's not on your test, okay? That is where we stop at 2.3. Midway through 2.3 is where your test will stop. Please use the remaining time to work on your review from the book and check your answers while you're working.